What is a logarithmic scale? Here, let's say, here I have, here are the years given to me, right? 2000, 2001 and all. So for example, let's say here on the y-axis, this is a 2, equally placed. When I'm talking about my points which are equal, I have a 3 here, 4 here, 5 here, 6 here, 7 here, right? This is typically the way we have the scale. This is typically the way we have our y-axis. But then in this particular case, when we have a logarithmic scale, it means that this value represents, for example, it is an exponent, yeah? So this value represents 10 to the power 2. This value represents 10 to the power 3. This value represents 10 to the, these are all equidistant, right? This value represents 10 to the power 5. Do you understand? Yeah, so this is my logarithmic scale. Yeah, this is 10 to the power 6. So what happens when you're moving up, the value is increasing very, very rapidly. Yeah, just like, we know the most common example is the Richter scale, right? For earthquakes, measuring earthquakes, which is again a logarithmic scale. So your every subsequent number on the scale is 10 times the intensity, right? So here also, with every 1 unit rise, you're increasing it by 10 times, right? You're increasing the value by 10 times. So this is the reason, look at this. Your 10 is over here, your 1000 is over here on the scale. Your 1000 and your 10,000 are equally placed. You see, on the scale, I would think of this as my 3, this as my 2, this as my 4, and this as my 5. You see, these are the powers of 10. The powers are equally placed, 2, 3, 4, 5. But then the number, as you keep going up, increases very, very rapidly, right? So, when you have a logarithmic scale given to you, as you go up higher, the numbers will increase extremely rapidly. Yeah. So here this question asks you, over the period depicted, the company that showed the greatest net increase in the average number of visits on its homepage. So, when I look at all these graphs, when I look at these lines, they all kind of make sense to me that they're very similar, right? So, the slopes are very similar, and well, this is starting from here and ending here. This is starting from here, ending here, kind of very similar lines. But I know that this is a logarithmic scale, which means that the higher up I go, the difference is going to become substantial. So take a look at this one. If I say this is my 70,000 value, right? And this is my value less than 4,000. So here the increase is of 66,000. Right, from 4,000, the number of in 2000, the page views went up to 2,000. In 2010, went up to 70,000, increase of 66,000. Look at the other values. The maximum, the higher end of these is, this one is 40,000. This one is less than 40. These are all, this one is like barely 9,000. You see, so definitely the difference cannot be 66,000 at all, because their higher limit itself is at 60, itself is 40,000 or less than that. So then automatically, the moment I see this, then I say that my answer over here is going to be this one, which is your company F. So my answer will be F, right? Do I have to compare it with all the, look, when we keep saying that, okay, it doesn't take time. I mean, of course, data insights gets a little, there is time crunch and all, but the point is to really understand things and observe, because then you don't really need to spend any time. When I say that this is a logarithmic scale, automatically, and GMAT makes it easy for you. I mean, there are hints always given to you. They're not going to try and make you do a lot of calculations, etc. You know that, right? So I already have a hint. It's logarithmic scale, which means automatically this is so much higher, the top line. The others don't match up at all. Here, this is 40. I mean, forget, the difference cannot, it doesn't even start at 0. Even if it were starting at 0, the difference would be 40 only, right? So my answer here is F. And then it asks about the showed the least net increase in the average number. So least increase from here to here. There on the same lines, I'm going to think, fine, this was the maximum increase. So most likely this is going to be the least increase. Again, logarithmic scale. This is at its lowest point. So this is about, less than, this is about 9,000 over here, right? And this is about 300 over here. So I see there is like maybe a little less than 9,000 is the difference over here, right? But look at this point, this is already 20,000, right? Over here, if I'm looking at this one, and here it is 1,000, already so much difference is there, right? Do you see that for all the other lines, the difference is increasing substantially? Why? Because their top points are going to be a much, much higher value, right? So automatically then I know that this is the line where I'm going to have the least increase, and this is then E, this orange line. Does it make sense? Yeah. With the logarithmic scale, people keep saying, okay, calculations, there are so many calculations that you have to do and this and that. Most of your graphs is going to be, and in fact, even your table analysis, most of them are going to be observation. Most of them are going to be about understanding, the data given to us, the time that we spent in understanding the kind of graph that is given to us, and then getting the answer quickly. Yeah. Yeah. Typically, the reason why people spend too much time is in case they don't understand the relevance of the logarithmic scale. That's it.